Should I start sharing already?
Yes, we are live.
Okay.
So I think in the interest or to give a couple of minutes to everyone, we'll wait maybe for a minute or so and then get started. And in the meanwhile, maybe Sham, you can share the screen so people can take a look at what is it that we are going to talk about today.
Okay. I'm sharing my screen.
Okay, let's just wait maybe another minute and get started. Okay, let's get started. Good morning, good afternoon, good evening to everyone. We welcome you to join this webinar on maximizing uptime and minimizing stress, and of course, picking up the right monitoring solution. I'm Satya here from the product team, and with me I have Sham. Go ahead and introduce yourself.
Hey guys, this is Shyam. I'm part of the NetData product team. And yeah, we're excited to bring you this webinar today.
Okay, quickly moving on to the agenda and the objectives. Sham, if you can switch to the next slide. Yeah, so quickly moving on to the agenda for today. We'll be talking about downtime disasters and the importance of effective monitoring, which Sham will take you through. Also about the pain points in general when it comes to monitoring. Uh, we'll also be taking you through the key or the essential features of a robust monitoring solution, alerting and AI or the anomaly advisor. And last but not the least, we'll give you a checklist for selecting the right monitoring solution whenever need arises. And finally, of course, time for some Q&A, but keep pouring in your questions and comments, and we'll try to take them as and when we see them. So let's quickly get started with some introduction on NetData. It's the simplest, fastest, and the most scalable observability solution. And over the next hour or so, I think you'll also understand why is it that we call it so. NetData provides high resolution and precise monitoring. So we track metrics every second and detect anomalies with our ML and AI also per second. So it provides you high granularity and surgical level incident management. It's probably one of the easiest tools to set up and use. It takes less than a couple of minutes to get started with out-of-the-box dashboards and alerts. And of course, the anomaly advisor with our insights and the anomaly detection. It also provides you great flexibility in terms of scale. So you can scale as you need with our horizontal and vertical scalability. It's also probably the most affordable monitoring solution with all of these capabilities. Most importantly, you can monitor practically anything and everything that comprises of your infrastructure, whether it is physical servers, virtual machines, Kubernetes clusters, multi-cloud deployments, containers, applications like your databases, web servers, IoT devices, data centers, or even supercomputers. That's a very quick overview of NetData. As you can see on the right hand side, we have millions of nodes being monitored as we speak on NetData. We have a huge and a vibrant community, uh, which kind of serves the purpose of an open source tool, which is how NetData started. And also now it being an enterprise solution, the community still is extremely active and vibrant. I think for the next section, which is to do with the impact of downtime and the importance of effective monitoring, Sham, I hand over the mic to you, and I'll put myself on mute.
Thanks, Satya. So I'm going to start by talking about the impact of downtime. And I know that to this audience, I don't really need to explain or define what downtime is, but I'll do it very briefly anyway. So, downtime refers to any period during which the system, the service, a machine, an operation, or even your entire infrastructure is unavailable or not functioning at full capacity. So, it's either fully or partially gone down in some form. That's what's referred to as downtime. So the amount of time, if you think of a year having 365 days and each day having 24 hours and so on, how many seconds and how many minutes, and God forbid, how many hours of that per year are your systems down, either fully or partially? That's downtime. And downtime is a big thing for enterprises, for teams of all sizes, right? You might be a small or medium sized company or a startup, or you could be a really big enterprise. Regardless, downtime is something that's really scary. It has immediate impact because your users are no longer able to use your product. So here's some stats just to start with. And I've mentioned the sources. So if you want to see, there's a lot more interesting stats there. 40% of enterprises indicate that a single hour of downtime can cost them over $1 million, right? So we're talking about $1 million an hour as being the cost of downtime for nearly half of the enterprise organizations out there. And Gartner's research identified that the average cost of 1 hour of downtime is at least 300,000, and this is at the average across all kinds of businesses, including the small ones. So you can see that downtime is not just something that big enterprises need to worry about. It's something that impacts everybody. And I have a couple of interesting anecdotes here. So last year, there was an outage for Datadog. It lasted roughly 24 hours. So it was partial in some places, and some users could not access the product at all. And during their earnings call, they said that it directly led to $5 million in lost revenue for Datadog. And it's kind of ironic that Datadog is a monitoring solution, but this happened. But this is how the world is. Things happen, and it's about how you learn from it that matters. And then finally, there's this anecdote about the Facebook outage. There's actually two separate outages for Facebook. So this one is referring to the 2019 outage, which lasted roughly 19 hours, and that led to a direct lost revenue of $90 million. Now, of course, Facebook is huge, so any outage is going to cause more lost revenue. There was another outage, I think, a couple of years ago, which didn't last as long, but impacted most of their services, including WhatsApp and other services. And that led to even bigger lost revenue. So, whatever we've talked about here, we're talking about the direct impact. The bigger impact, the broader impact, maybe even more. So, for a public listed company like Facebook, if there's a big outage that's in the news and lots of people find about, their stock prices are going down. So I read that the last outage, I think it was in 2022, which lasted a few hours. Mark Zuckerberg lost $6 billion from his net worth just because of that outage. So yeah, downtime is very impactful. So this brings us to monitoring, and specifically effective monitoring, and why this is really important. So effective monitoring is really the way in which you can systematically and continually observe your systems, your processes, your applications, databases, Kubernetes clusters, cloud infrastructure, whatever it is that constitutes your infrastructure. So you're continuously observing it, but you're not just observing, right? You're detecting if something goes wrong, or you're trying to understand if there are anomalous events happening there. And then once you detect it, you need to respond to the change. So you need to be notified if it's happening in the middle of the night, and you need the right people to be notified. And those people need to be able to use the tool to get to the root cause as soon as they can, so that they can keep the downtime as minimal as possible. And all of this process of systematically continuously observing this, it needs to happen in real time, because otherwise you're just missing out on data. Now, if you're able to do effective monitoring, this gives you a lot of superpowers, right? So it helps you detect issues and anomalies early. Sometimes you can actually prevent the downtime, so you don't need to wait for the downtime to occur and then fix it. You actually start to see trends and anomalies before the issue triggers something which becomes, a large scale downtime. So you can catch it early. So you might have alerts being triggered, you might have anomalies being identified, and then the right people can look at these things and fix the issue before it actually arises. This is the ideal scenario. You can also use effective monitoring for proactive problem solving, like I said. So a problem doesn't need to exist, but you can look at the trends of the data and then figure out this is where things are headed, and you can take steps to prevent it. It also improves the system reliability and uptime as a result of those things. So your systems would be much more reliable. Your uptime numbers can be much better if you have effective monitoring in place. In addition, it also provides a lot of good data for decision making. So the leadership in your company, in your organization, in your team, for them to make the right decisions about things like capacity planning, about having the right amount of people or the right amount of resources allocated to a particular service or a particular application, they need the data. So it's really important that they get accurate data to be able to make those decisions. And of course, effective monitoring will also help you enhance your security and your compliance. And overall, it just makes the performance of your infrastructure much more optimal. And you can see some of these numbers. I'm not going to go through them, but we're talking about real hard numbers here in terms of how much effective monitoring really matters. So if we talked about effective monitoring, so if it's so great, why don't everyone effectively monitor all their infrastructure, right? So there are a few issues here. So this is what we call cultural faults of the industry, which is that these are the things that make monitoring a chore, right? It makes monitoring hard, or it makes monitoring complex or time consuming. It makes monitoring not something that is enjoyable, right? So let's go through some of these things. The top thing really is that you know modern IT infrastructures, whether they're cloud environments or whether they're on-prem environments, they're they're alive, right? So there's things changing all the time. It's very dynamic. Your services are scaling in and they're scaling out, uh, and their performance is not really predictable. So in these sort of environments, you really need real-time monitoring. And by real time, I mean you need the data every single second, or ideally, even better, right? But what's happening in the industry is that most monitoring solutions do not give you per second information. They give you per 10 seconds, per 30 seconds, 60 seconds, in some cases even across many minutes. So what this means is if you visualize a chart, a time series chart which is going up and down, when you aggregate this into a minute or into a 30 seconds worth of information, it becomes a single point. Right? So you're losing all of those peaks, all of those troughs, and now it's being aggregated into a single data point. So you lose a lot of the story, right? So the data can tell lots of interesting stories. But if you aggregate, or if you shrink the data into smaller data points, you're losing a lot of the plot line of that story. So this is one thing which is a problem in general in the observability industry. The other one is having to cherry pick metrics. So think about this: your system and whatever is running on it, uh, there's thousands and thousands of different metrics that you could use to monitor this thing. Ideally, you'd get all the metrics, right? All the metrics are being collected and stored somewhere, so that whenever there's an issue or whenever you're curious, you have a place to go and look for this data. But what happens is, usually with tools, you either have to manually decide which metrics you need to monitor, for which you need to know which metrics. So it's kind of a chicken and egg situation, because you're not necessarily the expert of everything. And also with many of the commercial tools, the more metrics you have, the more you need to pay. So it becomes a cost versus value discussion, which is also not ideal when it comes to just visibility and monitoring. And of course, it's not just enough that you have all this data, but is that data actually meaningful? Is it telling you anything, right? So it's really important that the monitoring tool doesn't just dump a ton of raw data on you, but that it uses that data to tell you some stories, to share some opinions from the tool, so that you can actually make use of it in a much more optimal way. And that brings us to the next point, which is an expectation of expertise. So this is a cultural fault that we see a lot. There is an expectation that whoever is setting up this monitoring understands the applications that they're monitoring. They understand how to collect those metrics, but they also understand how to aggregate those metrics, the statistical knowledge required to understand how the time aggregation and the data aggregation works. They're also an expert in visualization to understand what sort of dashboard or what sort of chart types are the best way to visualize this. And they're also the experts in the application itself to understand what are the right alert thresholds. And ideally, they're even an expert in something like machine learning or AI, so that they can do anomaly detection, they can do forecasting, and all of these things. So it's not realistic to expect that the person setting up the monitoring is going to be an expert in all these things. So the tool should ideally help out the user rather than the other way around. Another pet peeve of ours at NetData is a lot of the tools expect you to learn a new query language, right? Whether it's Grafana, whether it's PromQL, or most other tools, they expect that you're now going to learn a new query language, which is usually a variation of SQL, and you're going to set it up to query specific data points and visualize it in a certain way. This is, again, it's counterintuitive. It's not normal for everybody to be an expert at doing this. And the learning curve keeps getting steeper when you have this in the picture. And then finally, assuming you have all the metrics, to create the dashboards and create the alerts, if there's manual work involved, then it takes a lot of time, right? So you're creating each of these dashboards chart by chart. You're defining each of these alerts metric by metric. It's a huge amount of time that's going to be taken up. And every time a new component gets added to your infrastructure, you need to do this again. If you're moving from one team to another team or one company to another company, you have to do this again. So as an industry, we're wasting huge amounts of man hours and just people's time doing stuff which is not very productive. So these collectively are what we like to call the cultural faults of the monitoring industry. And now we're going to talk about what the key features of a robust monitoring system, an ideal monitoring system, should be. And I'm going to hand it over to Satya again.
Thanks, Sean. I think we're just going to build upon what you just presented. So let's get to the next slide. So, what is the first key feature that we will look for in an ideal monitoring solution? I think Sham mentioned this on his cultural faults, is real-time monitoring. In today's digital era, 10 seconds, 30 seconds, 60 seconds means nothing. I mean, if you receive that data and you're trying to make some meaningful insights out of them and trying to, resolve your issues or find out root causes, uh, I think you're doomed. So what you need is real-time monitoring, at least per second metrics, per second logs. Even that is not good enough. I think going forward, it'll be milliseconds, probably at some point nanoseconds. Of course, it comes with its own issues. So why is it important to have real-time monitoring? I think Sham covered this briefly, but for issue detection, right? I mean, something went wrong in your system. Assuming you have a web server, you you either stopped receiving requests or there are a number of errors. There is an issue, but now you need to find the root cause. How do you do it if you don't have the data? So for immediate issue detection, it's absolutely imperative that we have real-time data in terms of metrics and logs. So we can then, in most cases, identify the root cause right away. Or even if not, if it's happened in millisecond timeline, it makes it much easier for us to make a guess, a more informed guess if you have data that's sufficiently accurate. Effective troubleshooting, right? I think I just brought this up. When in the middle of the night you're woken up at 3 a.m. For either resolving or identifying the root cause of an issue, you need to have all the data at hand. If you didn't, for example, if you didn't have all the charts or if you didn't have the metrics every given second, the time to root cause could be hours, could be in some time, in some cases days. And Sham already pointed out what it means, especially if it's not that you're trying to identify a root cause, but to fix an issue, and you had hours of downtime. So it's basically millions of dollars, in some cases even bigger. So for effective troubleshooting, you absolutely need real-time monitoring. Enhanced performance management. So I think for capacity planning, so if you have a good monitoring solution that has all the data that's coming in all the time in real-time dashboards, you can make meaningful uh, implementation in terms of how many resources do you need to allocate, how do you scale in, how do you scale out in a cloud environment, because every single resource that you have additionally will cost you more. But at the same time, if you have less resources allocated, it can cause you outages and downtime. So you need to balance between how much you want to spend, how much you want to kind of in terms of resourcing, how much you want to allocate. So again, even when it's not to do with an outage, when it comes to capacity planning and all of those scenarios, you would need real-time data coming in. Now we come to the next point. Okay, everyone I think agrees that we need real-time monitoring, but why is it so hard? Why not every monitoring solution can provide real-time monitoring? The first thing is the high resource consumption. As you can imagine, if I start collecting data every second, or even in the better case, every millisecond, means you're using your compute resources on your servers or wherever and whatever you're intending to monitor. So high resource consumption becomes a major deterrent when it comes to providing a capability like real-time monitoring. Scalability challenges. Of course, you could maybe for a small infrastructure with 5, 10, 50 servers or components of your infrastructure, you could potentially gather and capture metrics every second. But what happens if you have thousands and thousands of servers and you have a complex infrastructure, with multiple network components, multiple server components, a hybrid or a multi-cloud deployment? All of this becomes, way more complicated. But the most important reason when it comes to why most monitoring solutions cannot provide real-time monitoring is the cost implications. If you're using an enterprise grade monitoring solution, to name a few, the Datadogs, the Dynatraces, New Relics of the world, every data point that you collect needs to be transferred to a centralized cloud environment which they maintain, which means there is data egress costs for you. There's also data storage costs from the monitoring provider. And all of this cost basically adds on to your monitoring cost. And in principle, you're trying to monitor an infrastructure with a value X. You should only be, spending a small fraction of that to be monitoring your infrastructure. You should not be spending more than the value or the cost of your infrastructure in itself. Uh, Netdata, in principle, comes de facto out of the box with real-time monitoring. And the way we've been able to achieve this is through lightweight agents. So even though we capture data every second, and we do this by default for every single metric that we collect, our agents are extremely optimized in terms of performance. The second is, I think, the most important aspect, which is the distributed architecture. Uh, how and why we are able to achieve this is because we don't, basically do any computing on our cloud. So even if we have a cloud SaaS offering, all the computing overhead is at the edge. So it's being done on the customers or the users' infrastructure. So whether it's to do with collection, whether it's to do with compute, whether it's to do with storing the data, all of that happens on the edge. And that's why, when it comes to real-time monitoring, it becomes much easier for a tool like Netdata to cater to this. And I already brought this up briefly. All the data storage is also on the edge. So you don't, as a customer, need to pay for the data that's being stored on a third-party cloud, like the enterprise solutions. You would rather store it locally. Of course, this might still mean that you store it on your cloud, but you have complete control over how you store this data and how much you want to store and for how long. And that's principally the reason, right? Netdata is able to provide real-time monitoring. Now, to quickly move to the next topic, it's kind of related. The next and important thing when it comes to a monitoring solution is to be able to monitor everything. There's no point if you have an infrastructure, but you're not able to monitor various components associated with your infrastructure. Why is that important? I don't even think I need to go into this, but just for the sake of completeness, comprehensive visibility. Assuming you only set up your monitoring for your servers and VMs, but you had nothing for your network devices. Or possibly you set up everything at the system level, but you did not have anything to monitor your applications, whether it's your databases, your web servers, you name it. So if you don't have comprehensive visibility, more often than not, when it comes to a troubleshooting scenario, you would not be able to identify the actual root cause, right? So monitoring everything becomes important. It becomes very, very important, especially if all your infrastructure components are related in one way or another. And in most cases, they are. Improved troubleshooting, I think we brought this up. So in case there is an issue, let me give an example encountered on your CPU. There's high CPU utilization. There could be tons of reasons for you to have high CPU utilization. You might want to see, is this impacted by maybe some increased network traffic, which resulted in interrupts? Or is it some specific database server that has suddenly started misbehaving? Or it could be also lack of resources that have been allocated to applications and they are receiving more and more requests. So optimized performance. For all of these aspects, you need to monitor every component of your infrastructure in real time. Why is it hard? Again, I think most of these integrations, right, when you have to monitor each and every component, the integrations are themselves complex. How do you actually gather data? How do you gather metrics from each of these integrations? And that's one of the reasons, right? Different monitoring solutions have chosen an area that they are well suited for, and the rest of the components are left to either other monitoring solutions or they consider they're not as important. But that's again, when it comes to an outage, every single component of your infrastructure becomes absolutely crucial. Scalability issues. Again, when you monitor everything, it means you're gathering more data. If you're gathering more data, it means you need to send more data if it's a centralized monitoring solution. If you need to send more data, it means more egress costs. So again, it comes down to the fact that there will be high costs associated with monitoring everything in real time, although it shouldn't be that way. Again, quickly, how does Netdata solve this problem? with a unified agent. A single agent is able to collect data from all of your integrations, all of your components on your infrastructure. We have, I think, close to 800 plus integrations and even much more, because we are very well compatible with some of the standard, open source components out there. So whether it's a Prometheus exporter or it's an open telemetry exporter or a stats we are able to gather metrics from anywhere. We are able to export metrics anywhere. So we have created a great ecosystem. And again, we cannot stress less on the fact that because we have a distributed monitoring system, all the data is collected on an individual system. It's computed there, it's stored there. So we don't have the overhead of having to migrate data from one place to the other. Moving to the next component, which is time to value. Again, when you look at a monitoring solution, sometimes in bigger enterprises and in the past, in the old scenarios, let's say early 2000s, people always felt that to set up a monitoring solution, I need to have a big team, I need to allocate enough resources, I need to create a project to set it up and get it to work. But the more we get into the microservices architecture, how quick the deployment needs to happen, and how quickly you need to start monitoring stuff, I think time to value, which is basically how quickly can you set up your monitoring infrastructure, monitoring solution? How quickly can you start looking at your dashboards? How quickly can you start receiving alerts? How quickly can you start receiving insights? And all of these components become extremely important. And also, if the monitoring solution, like Sham mentioned in the previous section, if it collects a lot of data, but it does not help you focus on what really matters or what is really important, then the point is really lost. Why is it difficult to achieve? Again, I mean, depending on when and how the tool has been written and the architecture chosen, there is complexity associated with the implementation itself. The second one is the expectation of expertise. In many tools, especially when you talk about the Prometheus and Grafana's of the world, you need to set up the tool in a way that first you need to identify what are the components that I need to monitor, set up the exporters for these, have your Prometheus server collect all these metrics. But even after doing all of this, you don't see anything. You don't necessarily monitor anything or visualize anything yet. Then you need to go to a Grafana, create your dashboards, start visualizing them. More importantly, define how you want to visualize each of these charts. How do you aggregate them? How do you want to create alerts? And all of this becomes a manual exercise. So the expectation of expertise, basically to know what is important. How do I put this together? How do I get my teams to be notified at the right time when issues occur? And the last one, but not the least, is the lack of automation. Like I mentioned, since all of these activities need to be done manually, it makes it even more time consuming. So in some cases, I've been in previous organizations where it took us even 4 to 5 months to get comprehensive monitoring. And this was with a big team of sometimes 50 or even 80 engineers or SRE teams. So it is extremely complex. So I think time to value becomes extremely crucial. How does Netdata solve this problem? Yeah, our installation is as simple as copying a command, executing it on your terminal. It takes less than a minute or around a minute to be installed. It comes with automated dashboards, which has every single component of your infrastructure that you want to monitor. And it comes with also out-of-the-box alerts and anomaly detection. Alerts are set up already by default for all of the important components, but of course, for any custom stuff that you want to monitor and be alerted on, it provides you a tool that is flexible enough for you to be creating those alerts. To take you through the next couple of aspects around the important features of a monitoring solution, I hand it over to you, Sham.
Thanks, Satya. So the next category that we want to talk about here is the ease of scalability. Why is it important? This is obvious, I think, in most cases. You want your monitoring solution or your observability platform to grow with you. So successful companies will grow their infrastructure. You're not setting out thinking that your infrastructure size or your components are going to remain static. In most cases, they will change, they will evolve, and they will grow. So you want your monitoring system to be able to scale as well. Otherwise, what happens is that, you know, when you need to grow quickly, that's the exact point at which you need effective monitoring, because things could go wrong when you try to add new services and scale out. And it's really important that you have a really good monitoring solution in place, and that monitoring solution is able to grow as you grow. Um, the second point is cost effectiveness. I think we've touched upon this a few times, but let's say that you're growing and you're going from 100 servers or systems or cloud instances to 1,000 because things have gone well, more users are using your product, and you're growing. All of a sudden, your observability bill might now be a 5-figure, 6-figure, in some cases 7-figure number. So it's really important that when you invest time and money into a monitoring solution, you know that it'll not only grow along with you, but that once it does grow, it's still cost effective to use, right? So this is really important. And then bottlenecks. So when you're trying to grow, this is the time when bottlenecks start hitting you. The bottlenecks could be in terms of how your infrastructure is set up, whether there's interface issues, load balancing issues, and all of these things cause trouble for you. And the last thing that you want is for your monitoring solution itself to have certain bottlenecks, so that it doesn't give you the full picture, or it doesn't give you the full information that you need to make the right decisions. And the main reasons why it's difficult to scale adequately are, one is the architecture itself. So most monitoring solutions, especially the commercial ones, have this centralized architecture, which means that all of the data, all of the metrics, the logs, the traces, all of that information is being centrally collected to an instance at a server or a cloud somewhere. And this makes it harder to scale, because the more data that you have, the more logs that you have, the more metrics that you have, that centralized server needs to now be much more high powered, because it's a fat server, and it needs an unreal number of resources to be able to keep up with all of the data and still be useful. So that directly leads to the second point here, which is that this is very resource and intensive. Even if you're doing something at a smaller scale, and let's say you have a Prometheus server set up, and you had data coming in from 50 to 60 servers, and all of a sudden now you have data coming in from 1,000 servers. So now you need to think about how do you set up your Prometheus server so that it can actually handle all this data and still function. So you need to think about resources, you need to think about capacity planning, and it makes it harder and harder. And all of these things contribute to unmanageable costs at the end of the day. The costs might be clear costs in terms of how much resources need to be spent to manage these servers, to host all the CPU cores that you need, have all the memory that you need. And if either you're paying that cost on your own, or your observability vendor is incurring those costs and passing it down onto you with the markup in most cases. And it's not just the cost in terms of money spent, but also the time that you and your team will be spending on this. So the way that Netdata attempts to solve this problem is mainly through our decentralized architecture. So unlike most other monitoring solutions, the way that the Netdata architecture is set up is that each individual Netdata instance, what we call a Netdata agent, is fully capable monitoring solution of its own. So it can collect the data, it can store the data in time series database, it can visualize the data in dashboards, it can trigger alerts on the data, it can run machine learning for anomaly detection on the data on its own. But then they're also connected to each other, and you can have what we call Netdata parent agents, which are like mini centralization points. So one Netdata parent can get connected to multiple child agents, so that if you want to offload some of the data storage or the data processing, you can. It's a choice. And Netdata Cloud is is not a centralized data storage, but it's more of a distributed querying interface. So when you access your dashboards in Netdata Cloud across all of your Netdata agents, and you can have thousands and thousands of them, all Netdata Cloud does is run highly optimized distributed queries to pull all the data from all of these decentralized agents. So the data is all stored at the edge. So the data is stored as close to where the data originated from. And this is really useful for a variety of different things, which we'll talk about in the next few slides. And what this allows us to do is that, in theory, we can scale horizontally or vertically almost infinitely, right? As long as there's enough resources for running your Netdata agents, which you will have because this is your infrastructure, this is what you're trying to monitor. It really enables you to just keep scaling. So now that we've talked about scalability, let's touch upon data privacy. So data privacy in observability is something that's becoming more and more important. More and more companies care about this now. Now, there's certain kinds of industries and certain kind of organizations for which data privacy is like the number one priority, whether it's due to the compliances that they need to adhere to, whether it's due to the kind of product or service that they're managing or selling. But what we're seeing now is that, as more and more data breaches occur, and the data privacy regulations like GDPR and CCPA are becoming more and more stringent, more and more companies care about this now. So it's all important for obvious reasons. The confidentiality of your data, the security of your data, and it's also important for flexibility reasons, right? Because let's say that you have an infrastructure and part of it sits behind this demilitarized zone, right? Where there's no internet access, there's only offline access, but you still want to monitor those servers because they're running critical services for you, right? So we could be talking about critical infrastructure that's somebody's nuclear power plant, or the electrical grid system. These are highly secure environments in which direct internet access is a no-go. So are you still able to use your monitoring platform to monitor those things effectively? Because the other option is that you do not monitor them at all, or you monitor them in very rudimentary fashion. And that's not ideal either, because that means you're missing out on potential issues here. And this is, again, difficult to achieve with centralized architecture in general, because all the data is being hoovered up into a cloud somewhere. And for many companies, it's also about the business motivations, right? So they already have a centralized architecture in place. For those companies, it's very hard to move to a decentralized or distributed model. And their motivation is to convince users that it's fine, right? Data privacy is not the issue here, and that they are capable of securely handling your data, and that you should trust them. And that's a choice. Many companies may choose to do that, considering the convenience that it gives them. But it is something that you should be thinking about hard before you make that choice. And then resource usage restrictions as well. So if you have something behind a firewall, behind a DMZ that does not have internet access, are you able to monitor those things effectively? Is, again, it's a hard thing to do in many cases. So the way Netdata solves this problem, you'll see common themes here. So we've talked about the decentralized architecture again. So you can have Netdata agents, which are storing the data completely on-prem. You can even run the entirety of Netdata's cloud software on-prem, fully on-prem, which means there's no connection to the outside world. It doesn't need internet. It doesn't need any sort of callbacks to us as a company, and you can manage it on your own fully. All the data is anyway stored at the edge, whatever version of Netdata that you use. And I talked about the fully on-prem option that's also available for you. And then lastly, when it comes to a robust monitoring solution, especially in today's world. We think that it's really important that the troubleshooting tool set is really helpful and really useful to you. So it's not just that troubleshooting features exist, but that they're actually useful when you have a problem in the middle of the night that you're trying to troubleshoot. So because the worst thing that can happen is that you get an alert notification at 3 a.m. and you wake up, and then you're spending hours in that state trying to figure out what's going on here. What do I need to do next? What does this alert mean? So this is something that we take very seriously. I'm not saying that Netdata is the ideal solution here. We have a lot to learn and improve, of course. But this is something that as a company, we take very seriously. And we're really trying to do our best to do a good job here. And we're getting feedback from a lot of great users and customers. And we're trying to put that all back into the tool. So again, this is important for obvious reasons. You want to resolve your issues fast, which means that one, you need to be notified about the issue. And then once you're notified, you need to have all the right information in the right place so that you can take the right decision and get to root cause faster. So it really makes your whole operations much more efficient if you're able to do this effectively. And of course, you can do proactive maintenance. So you can have the right alerts in place, have the right machine learning in place, which will tell you that things are not looking right now. It may lead to an issue in the future, so that you can take action before the issue becomes a real problem for your infrastructure and before downtime occurs. So the reason why this is again difficult to achieve is that most monitoring tools have some form of alerts and notifications, but alert fatigue is a real issue because people get flooded by alerts, because most tools take the option that it's better to let the user know than not let them know about something, which means that you get a ton of these alert notifications, and then the user gets desensitized to them. So they're like, I get like 20 alert notifications every day. I'm not going to look at them. And that's not helping anybody. So what we need to do, and the other problem is that if you get alert notifications that are not descriptive or do not explain what the problem is adequately, then again, you're ignoring them because you don't know what to do with them. So this is the problem if you have unopinionated observability, right? Which means that your observability platform is just handing you the data without any opinions and saying, here's the data, go figure out what to do with it. But this is not an ideal situation to have in the middle of the night when troubleshooting. Similarly, how much information and knowledge does the tool package into itself, right? And it needs to do this in an intuitive way as well. You don't want to read walls and walls of text, but does the tool provide some information in terms of what is this metric, right? What does it mean when this metric is high? What does it mean when it's low? What is the expected value, right? What is abnormal? What is an anomaly? All of this information needs to be packaged into the tool, and this is not an easy thing to achieve. And of course, you need to do all of this keeping data quality in mind and have the right context along with the data. So in many cases, the data is just a part of the picture, and a lot of the juice is in the metadata. So the metadata can define all kinds of things about the metric. It could define how this metric should be aggregated, how should it be visualized, how should it be summarized, what sort of alerts does it have, what does it mean. All of this information can be put into the metadata. And again, this takes a lot of work, right? So Netdata tries to solve this problem through different means. We have different troubleshooting tools. We have hundreds of alerts that we've already built into the product. So you install Netdata, all of these alerts are already monitoring your system, and they will trigger, they will notify you. But of course, you can customize them as and when you need to. And Netdata's anomaly detection runs on the edge, just like our data storage and just like all of the other stuff that we talked about. So it's on the edge machine learning. And for every single metric that you have, and you can have thousands and thousands of metrics, for each metric, there's up to 18 machine learning models, really tiny ones that are being trained. And this is the default setting. Of course, you can increase it or decrease it as you wish. But what these machine learning models do is that it looks at what is normal for this metric in this particular instance or server or VM or container, right? Because what's normal for this metric in one server may not be the normal on another server. This is why we do it at the edge. And every time that it sees an anomalous behavior, it assigns a value to this. And it does this every single second. So for every metric, every second, we have a value, a bit basically, which says, is this anomalous or not? So if it's anomalous, the bit flips. And then when you look at this in the dashboard, zoomed out, what we do is we take all these bits and we aggregate them into what we call the anomaly rate. And this information is again available to you for each chart. Every single dashboard has the anomaly information baked in. So you don't have to go to some other dashboard to see, do I have anomalies? It's there. It's there in every single chart that you're looking at. If there's an anomaly, you will know about it, and you can then take actions. So this is what we're trying to build with our AI or machine learning first visualization, so that your AI insights are not a second class citizen. It's not something that you have to go and ask a chatbot, or you have to go and look in a different place to see your AI insights. It's just there. It's interspersed across all of the other stuff that you have, because that's how you use the product, right? It doesn't come naturally that hey, I need to ask my chatbot, what should I do next? That's not a natural behavior when it comes to troubleshooting a system. So this is again something that we take very, very seriously at Netdata. So I think we've done a lot of talking, a lot of slides. It would be good if we can jump into a quick demo and show you how this works. So I'm gonna change the screen share for a second.
Yeah, Sham,
Show you
just a time check for you. I think you
okay.
could, of course,
Sure.
give a quick demo.
Yeah.
But
I think we can go quickly here. Yeah. Thanks for the time check, Satya. So this is what Netdata would look like to you if you just sign up. And to sign up, all you need to go to app.netdata.cloud, sign up using your email, your Google, whatever, and you get this screen. And here's all the different places where you can install Netdata. So you for example, you can choose Linux and you get this command. All you need to do is just copy this command and then just run this command on a terminal. And within a minute or so, Netdata will be fully installed. It's as simple as that, right? And if you want to see, what things you can monitor with Netdata, you can use the same screen, right? So you go here are all the databases that you can monitor. Here's all the different applications that you can monitor. And there's hundreds and hundreds of these things. But, I would suggest go check it out yourself. Try installing Netdata if you've not seen it in action. And within that 1 minute of installation, what you would get is a screen which looks like this. All of the things that you see on the screen here are out of the box. I have not created any of these charts. They're all just there, right? So this is usually the wow moment when somebody tries Netdata for the first time. They just run that one line command and they get this full screen visualization, all of these dashboards, all of these charts, and you can see it automatically discovers what's going on, how many disks you have, what kinds of, what's going on with your memory, and then, what processes are running, who is consuming how much CPU, memory, disk. And then if you have custom applications that you're running, like Nginx, for example, all of that stuff gets automatically discovered as well. And if something is not automatically discovered, or you need to give it your credentials to your Postgres database, for example, you can do it directly from the UI. You just need to fill in like a couple of lines in the UI. It takes less than 5 seconds to do. And once you do it, you get this dashboard immediately, right? So what we're seeing here is a summary view of what's the status of Postgres going on. But then if you scroll down, you get a chart for each and every metric that we're collecting from the system. And there's probably hundreds of metrics just from Postgres itself, right? So you have database queries, throughput, cache, size, bloat, all kinds of stuff. And there's a lot of information that we're trying to pack into the tool here. For example, when you see something like table bloat size percentage, if you want more information, you can click on this information icon and it'll tell you what this means, right? So for example, here, I know the text is a bit small, but what it's saying is this is the estimated percentage of bloat in the table. And it's normal for tables that are updated frequently to have a small to moderate amount of bloat. So you know what you're seeing is this good? Is it bad? Is it ugly? So that's the information. And you have thousands of these metrics. You can create custom dashboards if you want to, but you shouldn't have to. And then you have the alerts tab, which shows you what alerts are active right now. This is our demo space, so there's a lot going on, as you can see. And again, let's say you see one of these alerts, QoS packet drops, and you don't know what to do about it. What is this? What does it mean? You can click on this button here, and you'll get an explanation of what this alert is. What does packet drops mean in this context? How do you troubleshoot this alert? And even some useful resources that you can go to read up and really understand this topic better. So the idea is not just to help you troubleshoot, but also to help you educate yourself. And of course, all of the charts that we showed here, if there were anomalies in any of them, there would be a purple bar that lights up on the top. So right now, there aren't any anomalies here, and that's why you don't see anything. But if there were, you would see it immediately. So that when you're browsing through and you see a purple color here, you know that, hey, there's an anomaly, and I need to look at this right now. So this is Netdata in a nutshell. There's a lot more I could go on about, including logs, Kubernetes-related information, our events audit feed, and there's a lot of information here. But that's going to be its own session of its own. So I'm not going there right now. But I really encourage everyone who has not tried Netdata before to just give it an install. It should just take a minute and just try it out for yourself on your system, on your server, on your laptop, whatever device you've accessed. So going back to the presentation, and I'm going to hand off to Satya for this section.
Yeah, I mean, this is essentially our last slide. So, we wanted to present you a checklist of things to look out for before choosing your monitoring solution. I think we've covered all of these topics through the previous slides. But yes, I mean, whenever the time comes and either you need to migrate to a new monitoring solution because your existing one doesn't serve the purpose, or you're not monitoring your infrastructure, which is even more dangerous, and you want a new monitoring solution, these are some of the things that you need to look for, right? Ease of setup, the learning curve. I think it's very important. It's underrated, but if it takes you months to just understand your monitoring solution, I would say it's probably not worth it unless you have the time to do it. Time to value, how quickly can you start monitoring and troubleshooting your issues? The metrics granularity, we're talking about real time, whether you need a real time monitoring solution, and I'm assuming the answer is yes, and whether the solution that you're looking at provides you real time monitoring. The metrics coverage, does it actually capture all the metrics across your all the components of your infrastructure? But most importantly, even if it does, is it comprehensive? Is it capturing whatever it captures in some kind of in sometimes in some way to be comprehensive, right? And then of course scalability. You might be where you are today, but maybe in a year's time or in a couple of years' time, you need to assess how big your infrastructure is going to be and whether the monitoring solution you're looking at can scale along with your infrastructure. The fault tolerance, is there high availability? What kind of reliability do you get from your monitoring solution? It'll be weird if your monitoring solution went down along with your infrastructure, so you had nothing to monitor. So I think this becomes a very important aspect. Intelligent default. So the monitoring solution by already, should come with certain defaults that make meaningful sense to you, even if you have to customize it later on. But you need to be able to get started up and quick. Data privacy, as we were talking, especially if you're dealing with a system that has confidential data or important data, you need to be careful about where you're sending out these metrics and data. And of course, the most important thing is the cost. And when it comes to cost, it's not just the direct cost that the monitoring solution is advertising, but it's also about the hidden costs. So if it takes you 10 resources with a month's time, that is hidden cost of monitoring. If it takes you, you know, egress costs on your cloud infrastructure, that is hidden cost. If it takes you more storage costs on your infrastructure, that is also hidden cost. So I think all of these aspects put together will give you a good idea of which monitoring solution you should choose, right, going forward.
And I think, we've talked a lot about Netdata, and we've done the demo of Netdata, which is our product. But what we're trying to do here in this checklist is to keep it generic enough. We think that you, in most likelihood, agree that these are valid things to look for in a monitoring solution. And we hope that when you're evaluating a new monitoring solution, whether you choose to go with Netdata or not, you still look at these criteria. And whatever tool you end up picking, you evaluate those tools for each of these things, right? Ease of setup and data privacy and cost and all of these things that we talked about, because this is what at the end of the day will help you minimize your downtime, um, and minimize your stress as well.
Yeah, I think we've run out of time, but we are here for a few more minutes. If you have any questions, please drop them on the comments, and we'll try and respond to some of them. And even if not, if you can't think of any questions right now, please do reach out to us on GitHub or Discord or any of our channels, and we'll be more than happy to hear from you.
Yeah, we'll keep our eyes open on all channels, so whether it's YouTube or LinkedIn or GitHub, Discord, anywhere you can find us. And just send us your questions, and we'd be more than happy to answer.
While you're thinking about your questions, we know we've spoken a lot. It might have been a little bit of an overdose, but hopefully, you can come back to this at a later point and try and assess if most of those things did make sense to you. Yeah, I think it was completely an hour, which yeah, we overshot by a bit. I think we were expecting it to be 55 minutes, Sean.
Yeah, thanks for sticking with us all this while.
Okay, we'll stick around for 3 more minutes. Um, and any questions that you have, please feel free to put them out on your comments.
I see some shout outs on the chat here, but I don't see any questions yet. Thank you for the shout out.
Yes, AI has indeed arrived to Netdata. Okay, I don't see any questions yet. It either means that it was extremely clear or it was way too much. In either case, we would like to hear your feedback. Do send us a note wherever you can find us, and we'll be happy to accommodate to that feedback and incorporate that to our next webinars. I'm sure we'll have many to come. And yeah, indeed, as Sham mentioned, we thank you all for staying with us. I know it's an interesting topic for everyone. Uh, so yeah, I think we've kind of come to the end of this. Thank you, Sham, for co-presenting. I think at least I had fun listening to all the great insights that you provided.
Thank you, Satya. Thanks, everyone. See you next time.
Thank you, guys.
Bye bye.
Bye bye.